Hey guys,
Ladies and gents,
mm-hmm.
theys and thems, what is up today?
Like 98% of our audience is like men, I think.
Oh, really? Okay. Well, I'm being inclusive, so
Yeah.
I just want to say
Tell your lady friends to watch this.
Yeah, thank you.
Got any.
Thank you for listening. Today we're going to talk about, I think the tentative name was RoadMap to Physics, but it's essentially we give our takes on how to solve physics problems, or what it takes to solve physics problems.
Indeed. So you guys should check this one out, especially if you're a layman or an enthusiast of physics. We give some tips about 10 minutes through on where you can do and what you can, what's just some ideas of how you can learn physics on your own if you're interested. And this was actually inspired by a comment that was left by one of the commenters on our community page. I'd like to go to it, but
okay. Well, let's just say,
it's okay. I'm sorry, man.
Let's just say we read the comments and we do take the feedback into consideration on like topics and stuff. So, so for that, if you want to know how to think like a physicist, stick around, or what it takes to learn to think like a physicist, if that makes any sense.
Mm-hmm.
Please stick around and like, comment, share, subscribe.
Mm-hmm. Check us out at Eigenbros.com, Eigenbros2 on TikTok, Eigenbros on Twitter, Eigenbros on Instagram.
Mm-hmm. And I think that's it.
Yeah, I think that's it.
Yeah.
All right, guys.
Cool. 3, 2, 1. We're live.
What up, folks?
Hey, everyone. Welcome to another episode of Eigenbros.
Mm-hmm.
Not special.
Ooh.
They're no longer special anymore.
Switching it up.
Yeah, a normal episode of Eigenbros. No, today we actually have a very important topic near and dear to our hearts, I think.
Is it near and dear?
I think it's near and dear. Solving physics problems is pretty near and dear.
Yeah.
Yeah. Especially for us lone wolves, you know what I'm saying?
Mm-hmm.
Like us characterized as lone wolves.
Yeah.
Self-characterized, So,
even though we're a show of two dudes, but that's true.
But in those classes, in physics classes, if you're anything like us, I think Terence has a theory on like if you're subscribed to personality typing, especially in the framework.
If for our usual audience, they know we're all into MBTI, so go ahead and preach it.
Yeah, unless you're part of the Big Five Peterson camp. Of personality typing, which I didn't know he was. I didn't know he was the main guy. Yeah,
I didn't learn that until like a couple of years ago, maybe.
I can't believe he's the meme. He's a meme now.
Yeah,
he's a meme for the wrong reasons, because apparently the Big Five is huge.
Yeah.
But if you subscribe to the more of what I personally think is a deeper, richer kind of a personality typing system, MBTI. Then Terence has like a sort of demographic POV of what at least in his experience, what the physics, how would you say, departments typically have.
Is composed of?
Yeah, mostly.
Oh, yeah, I guess so.
Like, what would you say is the personality type?
Well, I'd say experimentalists are mostly ISTJs or STJs, and then I'd say theorists are almost always NFs.
Mm-hmm. Interesting. So,
or at least in our department, for sure.
Yeah. I think in your undergrad, how did you feel about that?
In undergraduate, it was a little bit more dispersed, but it was a smaller school.
Mm-hmm.
So, it's a little bit harder to... Yeah, a little bit, but it's still kind of a little bit harder to say in that.
Gotcha. Yeah. Because I will say I've met very few NTs.
Yeah.
Intuitive thinking.
Where you would
types.
think they would be more in physics.
Well, it's because the icons are all... The icons are all like classic NT types.
True.
Yeah.
Einstein, Newton.
Yeah.
Except I'm not convinced Dirac is. People claim Dirac is INTP, but I don't think he is.
I don't think he is either.
I think he's an ISTP.
Bro, his like leaps are just so like, what? Where did you come up with that? And just
his TI was going ham in a interesting, unusual way.
He just it's weird. It's weird. I don't know how to describe it, but you see. There's a lot of.
What about Ed Whitten? I don't know what his is though.
I can see him being like a classic kind of caricature of a INTP.
That's what I was thinking as well, but I'm not sure.
A caricature. I'm saying a caricature meaning that you lean heavily on the typical order of the functions.
Mm-hmm.
You're leading
Supreme TI.
Yeah, Supreme TI. you know, sort of up next is NE, that's sort of subdued, and then like the real other last two functions are highly suppressed in some manner. For me, I'm more well-rounded, so it's like I look a lot less. I think I look a lot less like a character of an INTP.
Yeah.
But I think he's quintessentially.
You think?
The way the stack flows, it looks like that.
Not decided yet, but I was leaning towards that.
Yeah. I'd like to think the but in general though, I think. What do you think is a more lone wolf type of personality in the physics departments that get kind of lumped into this, like solving physics problems, for instance, like by themselves?
Probably introverts for sure.
Yeah.
In general.
Yeah.
But I think generally physicists are like that normally.
Mm-hmm. You're saying because their introvertedness.
Yeah.
But I like to think, for me, physics to me is more of a team sport in a lot of ways.
But you almost are like that too a little bit, Juan, because remember when I was telling you that before when we would do homework sometimes it would feel like you get left out because you prefer to sit down, you know, it'd be me and Javon would be at the board doing stuff. Then you would sit down and like start writing through problems first for like a good half an hour or so, and then you would jump in after you've like written.
Well, because I know what we're talking about.
Yeah, but that's why I think it might lend itself to introverts maybe being the lone wolves. But then again, Javon was always jumping in with me too, so maybe that's not true completely. Maybe it just depends on the situation.
Sure, but I think it plays onto certain strengths. Like for me, I can come up with the solution and like and I can work by myself. But the thing is, like whenever you work by yourself, it's highly inefficient. Because
you get stuck on stupid shit that
you can get stuck on things that are just somebody can figure out in like 2 seconds,
right?
Or maybe they see something you don't see.
Right, it's just a blind spot for you for some reason, or you're just. Your wheels have been spinning for too long and you're analyzing something in some dead end way where working with someone else can unlock it much better sometimes.
Because I mean there are techniques to this. Like I think as you go along in your career in physics or whatever, or maybe in general, just I mean we're going to keep this in the scope of physics. But like as you go along in physics, you'll see that sometimes there will be problems that leave you scratching your head. You're like, how is I can't figure this out, or you look at the answer, you know, and there's because there's some people that don't think you should look at the answer.
I
think you're one of these people.
Yeah.
But I think there was a quote by Feynman that I totally agreed with.
Yeah.
But I don't know if it's fake or real.
I know what you're gonna quote. I think it's real.
You think it's real?
Yeah.
Feynman was quoted to say he'll never start a problem unless he knows the answer.
Yeah.
You know what I mean?
Yeah, but I think what he's saying by that is, there was somebody delivered a package. That was your watch, right?
No.
Oh, okay.
Go ahead.
Yeah, there was a package that just got delivered, but we'll have to wait till after the podcast to get it. But so I was saying, what was I saying? Feynman.
Yeah, the
something.
Feynman quote.
Oh, the Feynman quote. I think what he was trying to say is that it's the same approach that I take, actually. Feynman being an ENTP, of course, so I think I can kind of speak a little bit of what he was thinking, although I will never claim to be a Feynman.
Feynman type.
I will say, I think what he was trying to say is that you should have a roadmap to how you solve things, which is ironically the name of this episode. Well, hopefully it is by the time I actually make the thumbnail for this and everything.
He'll see. He's thinking roadmap.
I think roadmap is going to be the name, something roadmap. But I think he has a roadmap for how to solve a problem. So let's say, for example, if I wanted to solve an E&M problem, right?
Yeah.
My roadmap is always going to start pretty much with Maxwell's equations. And I'm going to say, okay, which one do I need to use? Okay, I think that I'll probably need the Faraday's law because there's a changing magnetic field involved here. So, and then I could say, okay, and then that's probably going to give me, I'll be able to find my B field or something from that. So I do always have a roadmap to how I want to approach something, which is what I think Feynman's kind of saying. And I think you get that skill as you do more and more physics problems, right? I think when you're saying don't look at the answer, I necessarily wouldn't agree with that if you're a first timer or newbie physicist. I think you should definitely look at answers first when you don't know what you're doing.
Yeah.
Because then you'll be able to actually know what's out there and how to solve problems.
How to think.
Yeah, but then I think after a certain point, you need to cut yourself off and actually to start doing things from a fresh standpoint and try not to bias yourself at all. Because then you're just memorizing solutions rather than, or you're not really using your creative energy to actually figure something out, and you're just kind of regurgitating, which I think can be a bad thing to get into.
It can. I will say that if you're like me and if you're like a grad student, I think in general, you're going to be pressed for time. Yeah. And there is this like...
I think it's a temptation that you should try to ignore, though.
Yeah, I think it's more rewarding if you do have an answer, just give yourself a time limit, a reasonable time limit. Mm-hmm. You don't want to be staring at a problem for more than an hour sometimes because unless you really have free time, and then because I used to do it that way, just raw, like in undergrad especially, I used to just kind of, I mean, it makes sense when you're just learning.
Oh, I used to look at answers all the time as undergraduate. But that's because I didn't know what the fuck was going on.
I didn't. I used to I used to wait till, I guess it was just old school. Like I would just kind of have to think and then sit and then move on to something else and then come back to it later or something. And sometimes I'll like solve a problem in my dream and I'll find the solution, but it'll take time. It'll take a lot of time, especially when you're just learning. But as I got older and like, you know, you get more resources and like, I think online, like those online websites like Chegg and all those stuff like that have like solutions and stuff.
But those become useless in grad school.
They do. No, but I'm saying in undergrad, like as I was coming out of undergrad, like those were becoming popular.
Oh, right.
And I was like, oh yeah, that's cool. Like, you know, but even then, like a buddy of mine had an account and he would be like, yeah, dude, it's like, it's awesome. And I was just like, okay, that's good. And he's like, but it helped him get better grades overall. Like he would make great scores on his tests. As opposed to me, I would just be like a purist. I'm just like, no. Until like finally I was like, all right, man, you're making better grades, so screw it.
Give in.
Yeah, so like I guess it depends on where your philosophy stands. If you really want to get into a great school where grades are important, then I think you should prioritize on just learning the technique of it all, and not, you know, don't focus. You're gonna have to compromise a little bit of the understanding.
Yeah. I think the correlation between like how smart you are, quote unquote, and the school you're getting into is not as heavy as people think.
No.
I think it's mostly just how well do you know how to play within that system, which is fine and all. You know, of course, it's great if you can do that, but you also need to know what type of person you are. Are you someone who's more of like a person who does well grade-wise, or are you someone who's going to have to...
Well, no. How you emphasize... It's what you emphasize. Because for you and me, I think we emphasize understanding.
Yeah, that's what I mean.
Yeah.
But if you're going to emphasize understanding, typically you're probably not going to be able to do as many... you're probably not going to be able to do as good grade-wise.
Right.
Unless you already have a really good head start or something like that.
True. This is assuming that this is assuming you're starting physics in your undergrad at a blank.
Yeah.
At a blank state.
Yeah.
Because like me comparatively to other people that have had physics training beforehand or have like, I knew a guy who got into physics in his undergrad, but his dad paid for like a tutor for him the whole time. So he caught up. He was like, he caught up and excelled.
Yeah.
So it was like, okay, he in that way, like you might have to play catch up on another level. Like you might, to get to that level, you might need to go to like those office hours that they have at the libraries typically. You know what I'm saying?
Like
where they
SI
hire,
is what we call them.
Yeah, we call them
instruction.
Yeah. So typically at a university, they'll hire like a TA or even like a professor. I knew a professor who would like just go be an SI at the library, and I was like, that's awesome.
Nice.
He was a cool guy. He was so cool. Shout out to Larry. He was his name, Lawrence.
Larry.
Dr. Larry. He was so cool.
You might be a professor if
your name's Dr. Larry and you're teaching kids physics. Nah, but he was so good. But use those resources too if you really want to like I guess increase your level of understanding. But this is assuming the lowest common denominator, where you're coming into physics fresh, like me and Terence. You don't have any background in math. You're just being taught everything.
bit.
Well, you're being taught everything
Yeah.
at the ground level.
Yeah.
You know,
Yeah.
you come in with some rudimentary knowledge of algebra and all that stuff. So,
But let's gear this a little bit more towards people who now don't have any kind of physics background and they're not even in school. So I'd like to give a little bit of a roadmap a little bit. So what I did was for some people who are out there who are interested in trying to learn physics and you don't have, let's say you're just an adult and you've got a job at like a, let's say at a marketing company or something. You just like physics as a hobby or something you want to do in your free time. So I've did a little bit of research to see what's a good way to actually learn physics on your own. And I found that MIT Open Courseware is a good place to start. So MIT has these little open courseware things online. You can just Google literally MIT Open Courseware. And what you can do is they have on the website, you can go to actually find the courses. So if you go to find courses in the upper left tab and then go to topics, you can also select science and then the subtopic of physics. And basically what you do is you can filter it by undergraduate level, and they have a course on there called Physics 1. It's 8.012 if you guys wanted to use that as a course number. And that's the Classical Mechanics 1 Fall 2008. And basically what you can do is you can do those problem sets they give. So they give a few problem sets, like 6 or 7 of them. And they use the book, the Klepner, Daniel, Robert J. Cullencow, Introduction to Mechanics. And what you can do is you can actually just go through those problems, one by one. And literally the way to get good at physics is you need to actually go through problems. So that's a good place to start if you want to get problem sets to do. And then you just go through each of those one by one. If you just did like one problem a day, that would probably be a good start to getting you to do physics. And that book, I found that book online. It was about $20 or so.
Yeah.
But you can get a free version. Well, I won't say to do this, but there is something in existence called Library Genesis, where you can get many, many, many free textbooks.
Yeah, LibGen.
Not sure if it's legal. It's a Russian-owned website. That should tell you everything. But let's just say I do believe it is on there. Not condoning you go there, but
yeah,
I'm pretty sure it's on there. And it has a solution manual, I would imagine.
For the record, I also want to add something because I can think about a couple books that helped me along the way in my undergrad to problem solving.
Yeah.
And that is like how to problem solve too. How to think.
A book on?
Yeah, like or just how to think properly about solving physics problems.
Yeah, it's definitely a shift. If you're not used to solving physics problems, for me it was a big shift for sure, because I didn't even really understand how to. The biggest hurdle for me was to be able to simplify problems to fit in a very rudimentary, simplified model.
Right.
I tended to overcomplicate a lot of things.
Same here.
Yeah.
Yeah, that still gets me to this day sometimes.
Yeah.
Like we had a quiz the other day. I know, funny enough, we get quizzes in grad classes sometimes.
Yeah, I know.
There was a quiz
Ridiculous.
about a phase diagram, and like they were talking about, so phase diagrams are just like position and momentum in space, and like, so in an ideal case of a harmonic oscillator, right? So you can picture a harmonic oscillator like something that's oscillating in a pretty constant motion.
Mm-hmm.
It looks uniform. There's no friction in this picture.
Yeah.
If that's the case, then the phase diagram, quote unquote, looks like concentric circles almost. And in the quiz, it said what would the diagram look like for a harmonic oscillator with slight friction? And this is a
spiral, right?
Yeah, but this is a 8 a.m. class, and I was like, oh, it should look like concentric circles. And I try not to complicate it. My instincts told me the spiral thing.
Yeah.
So I was just like, I'm not going to complicate it. So this is me actively overthinking.
Yeah.
And so I ended up getting the answer wrong.
Yourself.
I tricked myself because my instincts told me. So that's one thing about overthinking. I still have it. Like my instincts usually give me the right answer about this sometimes. And I'm like, but what about this? And it's something that I think I fall into quite a bit though. Like I think you're saying you used to get into that.
Mine's a little bit different because the way I would overcomplicate things was like I remember I got stuck on a problem with a truck. So it was asking about like what direction was the friction for a truck or something. And I got focused on actually imagining the truck and the wheel and how the friction was pressing against on the ground. And it was messing up my direction of where the friction should be. And then I realized that, I should just, instead of thinking it as a truck, I think literally the teacher was just like, I think when I asked the teacher, he's just like, don't think of a truck, just think of a box. And literally if you just think of a box, the answer is just so much easier. Like taking the context, taking what can I say? Simplifying the model as much as you possibly can to where you're still getting the same information.
Physics,
you should always take that route. Like if you can make a problem where instead of thinking of a truck, think of a block moving on a surface.
Yeah,
that's how you should do it. It's like the spherical cow. I'm sure a lot of newbie undergraduate physicists, you guys love the spherical cow joke.
Yeah. Classic
so I'm
joke.
sure, you'll appreciate that. It's you got to simplify your models. You know, I always try to make things into points, lines, or squares. That's all. Points, lines, or blocks. That's all I try to do.
Or spheres or stuff like that. Simple
and
geometrical
sphere is even
shapes.
pushing the line.
If I don't have to use spheres, I mean, usually E&M I have to deal with spheres, but everything else I'm trying to get away from anything else but blocks, lines, and points.
This is the thing about physics, though. Like a lot of people love overcomplicating things, and like even in like these conversation pieces where people have of like brain teasers almost. It's all these problems can be solved by just simplifying the model down to its bare bones.
Usually.
Like there's extra dimensions of information sometimes, and they'll teach this in Physics 1 class. They'll add information that's not necessary to solve the problem.
Right. I think that can be a little bit painful in the beginning. That used to be a little bit of a pain for me in the beginning. Sorry, I'm trying to get this stupid thing to start back up.
It's fine. It's good.
Oh, it's counting down.
It's counting down. Bro, we got time. We got time here. Don't worry about it. We're killing the momentum.
Okay, there we go. So but yeah, so what was I saying?
In the intro physics classes. They introduce information that's like unnecessary.
Yes, so in intro physics classes they would do that to you sometimes. That pissed me off because I was like, I already don't get physics enough as it is.
That's true.
So when you're throwing in extra things to overcomplicate the picture to test me, it's actually really fucking me up.
It is kind of it's a really nefarious kind of thing.
They didn't do it too often, but occasionally you get problems like that, and that would really mess with me. Nowadays, now I don't need that because, I'm so adept now. I know what needs to be in there or not.
Yeah, and like, here's the thing, though. I noticed that as you get up to your upper division classes, they don't do that as much.
Yeah, because they don't need to.
But sometimes, we did this in one problem we were solving the other day.
I think you're
and
right.
We were like, that's kind of unnecessary information. And that's how I took it as like in the spiral problem.
Yeah,
the whole thing, I was like, a little bit of friction, should it really affect it that much? And then my instincts were like, yeah, it should still be a spiral,
right?
Because of the solutions, blah blah blah. But I was like, I'm gonna assume it doesn't affect it that much, and it's just like, oh yeah, every bit of information is important, and you need to
the right amount.
The right amount of information is important, and the professors argue that you have to think critically about this. It's true. It does force you to think, but you need to discern like what information is important and what isn't.
Yeah.
And how important it is.
That's the beauty of physics, where I think that's kind of where you lack what people lack in mathematics, at least early on. I don't know about the upper divisions. I think people in the upper divisions kind of get better at this, but one reason why I liked physics over math was the fact that physics forced you to actually be able to fit the most simplified model to whatever you're trying to analyze. No more complicated, no less complicated, right?
Yeah.
So it's like you're figuring out how to like clean up the messiness of real life in some sense.
Yeah.
To get exactly the biggest bang for your buck with the least amount of variables and things to manipulate.
Right.
So I thought it was very good. It's a very good skill for honing, really honing your critical thinking skills. Like I already felt like my critical thinking skills were very good, but this just made it very trimmed up even more so. It's just like it gives you exactly what you need to where you're not overstating anything. You're just giving exactly the right amount of information you need.
Yeah. Sometimes they'll break it down into easily discernible things like what's like if a problem is a problem will usually tell you what it's looking for, like what is blah blah blah. Then you know what variable you're looking for. What it'll guide you towards the answer in that way.
Yeah.
But a lot of the time at the upper levels things get more clever. But as far as undergrad goes, I think navigating that whole road, I guess, is a lot more clear cut, I think.
Yeah.
Unless you have a professor who's an asshole, then that's a whole different story.
Yeah, you're gonna definitely get those.
Yeah, I will say in your undergraduate career, you'll probably have at least two that will try to.
Assuming they're gonna have an undergraduate career.
Assuming.
Because also this episode, I want to make sure it's for people who aren't gonna be in school necessarily.
Gotcha. Well, let's just say you're taking those MIT Open Courseware classes. Yeah. You will. Their professors love putting in clever things that. It's not necessarily they expect you to know.
It's just testing your knowledge.
It's testing your knowledge, and a lot of the time they don't expect you to get it, but it's something that you'll walk away appreciating. Yeah.
You know, one thing I did not like about the MIT Open Courseware stuff is that, much like Ivy League schools do, they always have to overcomplicate shit because they need to, justify their tuition and egos. But it's good if you want a little bit of a challenge, but also it could be a little bit complicated. They have a little bit of extra complexity that seems a bit unnecessary in my opinion, but it is a great resource just to have a bunch of disposable problem sets and solutions, and also other resources that that you can go on YouTube sometimes and find video lectures. So it's got a lot of bang for its buck, all for free. But also do take it with a grain of salt. It is an Ivy League school, so sometimes it's going to be a little bit, in my opinion, overcomplicated. So if you want to find other means, I would just do, like, for me, I would probably just do this. I would probably actually search like my local university curriculum, physics curriculum, and then see if they have actually any problem sets. Because sometimes, at least physicists used to do this. They used to leave up their problem sets and stuff online, like, because a lot of professors had their own websites. Of course, now it's shifting a little bit because professors now use like certain proprietary software
in Canvas.
To keep like, for us it's Canvas, to keep all of their stuff in house so that students aren't downloading old solutions and things. But there are remnants available in this world still. You just have to know where to find them. So yeah, if you can find those in your local university, usually those problems will be more simplified. Or even what I do sometimes is just like, search the bottom 50 physics schools in the U.S. and then the lowest,
No, that's a good idea.
Yeah, search the lowest physics schools in the U.S. and then take those problem sets, and then those will be a little bit more simplified usually, which to me is like, there's no shame in that. Like, go simpler if you can. All great physicists believe in simplicity.
And there's
simple.
There's also the fact that in physics, despite what you hear, there are only very few clear problems that are solved, like real problems. Like in quantum mechanics, there's like a couple clearly solved problems. I don't know how else to put it. Just the
physics is not going to change. If you go to a shitty university to learn physics, it just might mean it might mean you get less. You get less physics or something, but
no,
physics doesn't change.
The translation usually is that you probably won't have a TA for the class.
Yeah.
And it'll be harder to learn. You'll have to teach yourself more. At least in my experience, that's how.
You kind of already have to do that, though.
I know, but
physics
I'm saying, but I know MIT, they have a TA, they have supplemental like classes.
Okay,
apparently.
sure.
They have a lot more of a support system. I think unless comparatively now, like if I compare my graduate university versus my undergraduate, my graduate university has way more resources to help the student versus my undergraduate.
But that's also why I say less physics too, because then you have a less availability of professors to be able to teach all kinds of other classes too.
Right.
Like at my school, I don't even know if we had quantum field theory.
Yeah.
Like we might have, but I don't remember anybody talking about it.
Yeah.
So I don't know. I won't say for sure if we did or not, but I don't remember it. I never even heard of it until I came to this school.
Dang. Well, I mean, there you go. Like there's the real difference here is money and availability of resources, and already
and networking opportunities.
And obviously, that's like one of the benefits. But for the most part, you can teach yourself. It's just you have to work a lot. You have to put a lot more time into it.
Yeah.
Now, if you're casual about it, if you're a casual learner, then I would say pick up books. Like go on Amazon. You can pick up the Dover series textbooks. Here's the theoretical physics.
We use Pearson as my school.
Gotcha. No, we didn't use Dover. Dover's too
advanced,
too deep.
Okay. I would recommend go simple at first.
Yeah,
go with the available resources. Like another thing is physics students, usually an undergraduate, do a lot of online problem solving. So if I could recommend you to even like, let's say if you get a Pearson book, a lot of times they'll come with a book code where you can actually do online homeworks. And those are really nice sometimes because they actually will walk you through the steps. Like it won't hold your hand, but it will say like, give you hints if you mess up. And that actually helps me a lot. I like those a lot, even though a lot of people complain because sometimes when you would enter an answers wrongly, it would penalize you. But, if you're doing it on your own, then it's great. And you can actually do self-study on some of those programs.
Let's just say you want to cover physics like just literally so casually that you just want to read a book about physics. If you're on that level and you basically want to get the equivalent of a BA education, not the BSc. Bachelor's of Science being that you take math classes.
Yes, which is pretty important with higher and higher levels of physics.
Right.
You're going to need calculus. So if you really want to start on anything.
Well, let's just see I'm creating the two lanes in a sense.
Yeah.
Where, you can still do a lot with a BA, but it'll be less mathematically rigorous. And that's not to cop out a BA or give a BA a lower status.
Well, it is because it's less school.
Sure, but in terms of like knowledge,
it's going to be less.
Sure, but I'm saying, like for instance, Carl Sagan, for instance, he only had a BA in physics. Yeah.
Oh, okay.
Yeah. So he got pretty far.
Okay. Yeah.
So I'm saying depending on what level of physics knowledge you want to get to.
I thought he taught it at university.
I think he's one of those guys that are given like honorary PhDs. You know what I'm saying?
Damn, that's what I need.
Yeah, where you're just
honorary PhD. That's
you get to a level where you're just so
you're just so influential.
Yeah.
Help the Eigenbros get an honorary PhD. I mean, maybe Juan will actually get a real PhD, but I won't.
Terrence wants an honorary PhD. Let's get him to an honorary PhD level.
Rally me, whatever petition you got to sign, get me on an honorary PhD petition.
Yeah. So but I'm saying but you actually have a BSc, so So yours is a little more analytical of a degree, but let's assume that you want to take the route of a BA.
Mm-hmm.
Somebody who likes science, the science of physics, but doesn't necessarily like the math. Because truth be told, the math...
Well, the thing is, so I'm sorry to stop you,
Go
but
ahead.
I got to say, the real way to learn physics, though, is you got to like math. Because you can watch our channel and get a good conceptual degree in physics in some sense.
Sure.
I feel if you watch our stuff, you'll be able to get a good sense of conceptual physics.
Yeah.
That's not really physics, though. That's like you're getting you can get that in many, many places.
Mm-hmm.
If you really want to learn physics, you need to be doing equations in math. You need to understand how to relate real-life phenomena into an equation. Like you need to be able to look at something and say, oh, these two things have a relationship. I can actually write an equation down to quantify that relationship.
Yeah.
That's the separator between like actually doing physics and just like being a physics enthusiast.
Well, truth be told, you can do it. You can talk about it. Like you can get a BA and still talk about physics, but you will sound more like a philosopher because you don't. Let me explain. And the reason why is because mathematics is a good symbolic language to represent in shorthand form a lot of information. Do you know what I mean? An impossible amount of information to just speak about. Right, a lot of
when you're getting high enough level.
Exactly, yeah. So in some ways, math becomes like
critical.
Yeah, it's like it's much better. It's much better to use math to talk about physics as opposed to language.
I just think it's not even possible to like.
You can, but bro, it'll be pages, and you'll lose.
Yeah, like
you can lose a lot of information in that.
Yeah, and the thing is, like, I couldn't even imagine like trying to prove like some general relativity concept that has a bunch of Christoffel symbols and shit in natural language. Like, that would just be the most absurd thing ever.
So many run-on sentences. Yeah.
Yeah, and like.
So then, what you do is you imagine that,
and like having someone try to even like confirm that too with no mathematical framework would just be ridiculous.
So just internalize that in your head. If you really want to really understand physics, you almost reluctantly need to pick up the mathematical like language, but it's just the thing that you need to do.
Like, you need it. How do you even convey like a geometric thing? Like, how do you even convey like a Pythagorean relationship without math? Mm-hmm. Like, how do you even say that in natural language? A squared plus B squared equals C squared. How do you even say that? You take the two lengths of the sides, and then it should equal the. But see, do you see how much language I have to use to say the same thing? You can say the same thing, but it'll take a paragraph maybe. But then you have to also say like two lengths multiplied. Like, how do you say that?
Like how you said it.
But multiplied is math.
Oh, no, but that's what I mean.
How do you even say that without mathematics at all?
Oh, no. I'm not saying that. You're still involving math, but I'm saying the condensation of you're condensing.
But then that's still kind of a cop out because that's still math.
Yeah, but I'm saying like writing it out, like, you know what I'm saying? You can write it out, but it's just going to be such a mess. You need to be able to symbolically represent
right, but that's still math.
Operations.
That's still math. So you can still say it. You can still talk about GR by speaking, but you need to still be able to.
No, but I'm saying you can talk about operations, mathematical operations.
Yeah, but that's still math to me. That's still kind of in the realm of math, right? Because you're still able to use math. Like, I can talk about GR stuff and like bending of space time and things, and like a physicist will be able to get that.
Yeah.
But if you have no math, the higher and higher orders you have of no math, the more and more impossible it's going to become to talk about anything.
Sure, yeah.
We're taking like addition and multiplication for granted, but those are still mathematical concepts that have some weight to them.
Sure, but I mean, multiplication is just the condensed form of addition.
Yeah. But then you have to try to think, how would you convey the Pythagorean theorem without
any math?
You're saying without any symbolism, essentially.
Yeah. I don't think you can do it.
I mean, you can say like you take one length.
Length is already
double its length.
Mathematical.
No, but you need that. You can talk about it like that. But the thing is, the point that I'm trying to make is that you can talk about it like that. But you're going to waste your time. You're wasting your time.
But that for me is an example of just what happens when you get to higher orders. Mm-hmm. So I'm just trying to use that as an example because everybody knows algebra and multiplication, right? Yeah. Pretty much, most of the audience will. But now try to imagine that. That's how ridiculous it's going to be if you don't know like vectors or vector addition or like tensors or a thing. Well, maybe not tensors. It gets high level. But,
yeah.
Or like quantum mechanics. You can't talk about quantum mechanics at all. Mm-hmm. Like, I'm sure many people have seen all the quantum explanations out there and how they don't make any sense.
Yeah.
It's because we don't even have the qualitative framework to be able to talk about it. So if you have no mathematical framework, now you really got nothing.
Yeah. But that's why it's useful to see the math, though. That's where I think you need to get comfortable with it. It took me a long time to get comfortable using mathematics as a language.
Same.
Because you kind of, especially for me, I didn't have a good math background coming into college because honestly in high school it wasn't that great, no disrespect, but like to the school district that I went to, but they had coaches teach math, which was like abysmal. And like
how many yards does Timmy have to run to get this?
I was just like, what? I don't even it was insane. But like not to knock them because they were good, they were probably good teachers, but
they were phoning it in.
I don't know. I maybe I was phoning it in. I don't know. The thing is, it didn't stick. And so when I got to college, I was like, oh, I'm not good at math because I'm just not one of those people. But I was perfectly capable of abstract thinking and like doing all these kind of operations and just, it didn't make sense to me at a point where I'm like, why am I not good at math?
Yeah.
And so I understood that at some point I was like, oh, maybe I'm not good at math because I haven't really learned it well. And so if you're one of these people, don't be afraid to teach yourself math, because you can. It'll take it's a little bit of a pain
Yeah.
in the ass, but
It's so worth it though.
yeah.
I'm the same way as Juan too, because I mean, mostly my aversion to math was I just didn't see a use of it.
Right.
I just didn't understand why I would ever give a shit about math. There's actually a tweet that blew up. I don't know if you saw this girl Gracie G Cunningham or something.
Oh, the TikTok.
Yeah.
I did see
she
that.
was talking about like what the is even. Well, she didn't say that, but she's like, who even came up with these theorems and everything.
Yeah.
And I thought the support for her was good because it's like that literally was me in high school. I was like, and I think a lot of physicists can relate to that. Yeah, there is no point really in high school because we're not told the basic, like, what is the purpose of this? And you kind of need that to have any kind of motivation to do things, I feel like a lot of times.
Well,
like,
I think for certain personalities, you need to stress the utility of certain things. Like with English, for me, I was really good at English, but it's because it's obvious its utility is like,
yeah,
it's
very clear from the get-go, right?
Yeah.
You need to be able to speak so people can understand what the hell you're saying.
Or writing or whatever, that kind of thing, or just even talking about relating to stories and people and stuff. That translates easily in the human sphere, but like math, you're just like, what is this for?
Like, my mom doesn't use this really. I don't see anybody using this.
Everything
like,
is automated.
Who's this for?
Yeah.
Who's the guy that needs this?
Yeah. I'm not raising goats. Why do I need to count how many apples
Right.
I need to make before the fall? Like, yeah.
And it's funny though, because even people that you don't think use math actually do. Like my dad uses math, and I didn't realize that he did.
Yeah.
So it's like we need application and like just a sense of showing people why this actually makes sense or is necessary.
Yeah, and that brings me to the one class where it brought it all together, and that was calculus. For me, calculus was like this awakening in my brain that was like, wow, math is so powerful.
Yeah. So
powerful. It made things. Now it made me see the utility of math in a way that I started to be able to describe things that I saw in reality in some way. For instance, in calculus 1, they teach you about gradients. So they talk about planes, right? You talk about like
I never learned gradients until Calc 2.
Well, I mistakenly took an honors class, and that was a big mistake on my part.
I think easier to just say slopes.
Yeah. So I mean, let's just say So they talk about slopes, right? But you can easily apply this to a field, meaning like a 2-dimensional like space, right? Mm-hmm. The professor was talking about gradients or whatever, and he was like, this is why water tends to collect in the lowest. The local
minimum.
Mm-hmm. So like, for instance, if you see like a pond or a lake or something, that is a local minimum in this space around you. And I was like, wow. I had that GIF of
Eric,
Tim and Eric show.
Yeah.
Where it's just like my brain was just blown away. I was just like, wow, I'm starting to piece these things together where it's like, oh yeah, this thing finds its lowest energy, and that's technically the lowest energy that it follows the gradient or the slope of the earth, and this is where you get the local minima. And so
you're starting to see the mathematical proofs for things that you might take for granted in normal nature.
Yeah. And
you're like, oh, like this is literally the math is telling you that this is what's going to happen anyway. Like,
yeah. And that's so applicable to real life, because then imagine if you're lost in the world somewhere and you're like, I need to find water. Where can I find water? Okay. And you're stuck on a mountain or something. You're like, I need to get off this mountain to find water, because the water's going to find the lowest, try to collect at the lowest point. So you can think about these things and abstract them in a way that's like, oh, this is all very useful information. And it was so cool. It was incredibly rewarding. So Calculus 1, I would say you can pick up a book. I think it's I read, it's literally a book that you can read in like a couple hours. It's Calculus the Easy Way, I believe.
Okay.
I think it's the name of the book, and it was very informative.
Author?
And I don't remember the author.
Okay.
I'm gonna give you the picture, but
Okay.
so if you're interested in the book, I think I'll have Terence put the image up on the
Okay.
YouTube. But yeah, or on the show notes as well. So pick that up. It's a good book to get introduced to the history of calculus and how useful it is, and breaks it down in a very easy language. Incredibly rewarding, I think calculus is in my experience. So what about you?
I think what was that?
You feel the same thing?
Yeah, I think if you're trying to learn physics for sure on your own, a great way to start would just be like go calculus first. Because if you know calculus, that's like the main thing you need to know, like all the most deepest concepts in physics. Of course, it does branch off to things like linear algebra and tensor calculus and all that stuff, but calculus is the root of like all physics. So like you'll learn so much. You will get so much bang from your buck just learning the three main important things of calculus, which is just limiting cases, derivatives, and integrals. If you just know those three things, you'll get a shitload of return on your investment if you just study those things.
Yeah, and you can just honestly, and those are all very popular, easy. Probably there's so many resources out there to like teach calculus at this point that you can easily teach yourself.
Yeah, Paul's Online Notes is a great place to start with that stuff. I've noticed.
Stay away from Wikipedia.
Yes, Wikipedia is a little bit like over the top. It starts saying shit in all kinds of like. It does this thing that I hate when people do. It's this thing that's where it's like when people learn enough math to such a high level, they think it's actually easier by giving the higher order explanation. It's like, oh, it's just a commutative ring on a two-dimensional manifold in Hilbert space. I'm making all that up, but like that's the kind of vibe you get with Wikipedia sometimes. It's just jargon. Like, this doesn't make any sense to me. This isn't useful at all.
Yeah.
So it overcomplicates things by thinking it's saying it's simpler, but it's only simpler if you know that many higher orders of mathematics.
Exactly.
So
don't go to Wikipedia for trying to learn this stuff.
Yeah.
you will be like, well, I guess I'm not going to learn calculus.
Yeah.
You can. I'm just saying the people writing these Wikipedia pages are
go to like Patrick JMT.
Right.
I don't know if he's dead. I don't know what happened to Patrick.
Let's just hope he's alive.
I really hope he's not. And now that I say that, I really hope he's not.
I hope he's not.
He hasn't been online in years now.
He's a legend.
But he is a legend, a true math mensch. He has a shitload of videos on calculus and stuff that I used for when I was an undergraduate.
Same.
Great, cuts right to the chase. You know, if you want to go to that guy, he will teach you a bunch of math. Salman Khan, another great guy. If you want crazy explanation, conceptual, 3 blue, 1 brown all day. Another badass dude is Black Pen, Red Pen. He does all the weird, cool stuff. Flammable maths. I got tons of people. Those are all YouTube.
And that's for
people.
calculus. For physics, though, Van Biesen.
Oh, Michael Van
Legend.
Biesen. Yes. So if you guys are trying to learn physics on your own, Michael Van Biesen is a great way to start because that guy does not mess around when it comes to like showing you all the steps of how to do things. He's helped me so many times, and even in graduate school, when I'm trying to remember something, he helps me remember the intricate parts of things that you forget about.
Yeah, the fundamentals. That
Michael Van Biesen, great dude.
Yeah. He's he's so good. He's such a legend.
Yeah, probably my favorite of the physics solver guys.
I think I'm inclined to agree. Yeah. But like standard solving physics problems. Yeah, he's the guy.
There's another guy who had pink paper who was pretty good, but he had really long videos.
No clue.
Oh, Dr. Physics A. He's okay. His videos are a little dry, blurry, really long, but he has a couple gems out there where they'll give you some insight. But
well, pretty soon we'll be in that camp, Terence.
Hopefully soon.
Right?
Hopefully soon. So we're trying to open a second channel here.
Yeah.
I've already announced this, so yeah, they should know. I'm not going to backpedal now.
Yeah.
But we're trying to do some physics problem solving stuff too here in a bit. So hopefully we can actually make some things understandable for you guys too. And I like to pride myself on, being a good explainer. So
Yeah.
we'll see. You guys can be the judge of that.
Yeah. Terence forces me to really, really, really not walk away with bullshitting myself.
Yeah.
It's very easy to bullshit yourself, right?
Yeah, in physics, yeah, it is
So
100%.
easy.
Yeah, it is. Because, yeah, I mean, sometimes you'll see. I mean, the most classic example is Dirac coming up with the correct answer, but some weird fucking logic. And it's just like, what?
Yeah.
Yeah. I think we've talked about it enough that you guys know what we're referencing. But yeah, it's just you need to be careful to like fact check yourself, and that's another important thing if you're gonna teach yourself physics is if you're pressed for time and you're like, I want to figure this out, but this doesn't make any sense. This is where you go to those YouTube channels, cross-reference. You can look at textbook materials, but I will say, as somebody who goes to textbooks often, as Terence will tell you, it's time-consuming.
I'm a YouTube guy much more. Juan's more of a book guy, I think, right?
Yeah,
Juan,
I'll reference books first. If the books don't add any clarity to it, I'll typically my typical order is books first, then I'll go to a person. It could either be a peer or even the professor, if they're immediately available. If not, then I'll probably just go to YouTube if all else fails.
So I haven't looked at a book in years. I just I go to either Wiki real quick or I'll go to YouTube.
Yeah.
YouTube is my shit.
Yeah.
So, and I like to just see the person work it out, and I see immediately the thing I'm stuck on. And I'm like, okay, that's it.
Yeah.
So, just depends on your style too, right?
Yeah. But I will say my style is inefficient because like I waste time. Well, it's a waste of time, sort of.
Yeah.
But it just depends on what you want to get out of it. Like I will say, if you just want to solve the problem and move on, then go the route of
especially Wiki.
Wiki could be good for that if you just need to look something up real quick.
Oh yeah.
Or actually, really good hyperphysics. Hyperphysics has given me so many quick, just like, oh, that's exactly what I wanted.
Yeah.
Because sometimes you'll type in things in other websites and they won't get you exactly what you want. But hyperphysics is one that just goes right to the kill, and you're just like, that's exactly what I'm trying to do. You don't need any extra frills, any of this. Just give me what I want.
Yeah. He'll show the equation. Bam! Yeah. Right there, right when you open the page. HTML.
Simple explanation.
Yeah, HTML. These are the variables. These are what they mean.
No commutative rings on a Hilbert.
No, nothing like that. Nothing too complicated. Yeah, so it's good.
I'm sorry for any triggered mathematicians out there. I don't think that doesn't make any sense. I'm sure.
Yeah, I'm sure it doesn't.
I can probably make up such good Star Trek jargon though now, just with all the crazy terms I know.
Yeah, the flux,
or like a good Deepak Choprian quote.
Yeah. No, but that's how all those sci-fi, they just had to mention flux capacitor, supercharging, quantum interference.
Yeah, quantum's always the way to go.
Always. For sure. Anything that you want to add.
Anything magical.
Quantum.
Yeah. But yeah, man. I guess, is there anything else? I think because I wanted to hit on like just calculus being really important to learn. The problem solving techniques. I guess I should add that at the end of the day, if you want to talk about physics in an analytical sense, it really comes down to learning the fundamental equations, what they mean, but then also applying them to boundary conditions. And
that's a little bit more high level, though.
That is high level, but yeah, that's.
So I didn't really start even thinking about boundary conditions until like my third year in undergraduate or something.
Makes sense. Makes sense.
Yeah, like I was just really trying to figure out what's going on here with these equations. How do I solve these problems? Classical mechanics is a great way to start because you have all the intuition there. When you start to get into weird shit like quantum and GR
and E&M even.
Like, this is one thing that I think that I'm glad I have got in my life that I think a lot of people don't even know in regular life. You do not have good intuition for the small, the very, very, very small, the very, 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 and the very, very, very fast. And even maybe the very, very large. The very, very large is a little bit more classical, but very small things and very fast things, humans have really bad intuition for. And you really don't even know. Sometimes you probably won't even know what that means if you're not in physics. But your intuition truly breaks down in a way that you don't see anywhere else, I don't think, except for physics. Like, because generally in physics, I feel like my intuition is pretty damn solid when I'm doing classical mechanics. Like, I'm like, oh yeah, I got this. I can figure this out just by visualizing it in my brain. I see the picture in motion. I see how these systems are interacting. But when you try to do that in quantum, I mean, it's a fail unless you build your quantum intuition. Now I can do it because I have quantum intuition, but I have to switch into that mode. A little bit easier with quantum because the math is a little bit more straightforward. But when it's GR, like general relativity, that can get pretty bad. Yeah, that's a bad shift for me.
Yeah, that's a big stuff.
I can barely shift in even right now into my GR mode or special relativity mode.
That's hard. Trying to even visualize that stuff with weird like length contraction and time dilation and that kind of stuff.
Yeah.
I mean, it gets
it's just good.
tough.
I mean, there's good like little like tidbits of like, how would you say,
like
phrasings?
Axioms or something.
Just like for instance, for special relativity, it's like the faster you go, the shorter it gets.
Yeah.
That's a good one.
I believe that was a tweet that you made a while back.
No, I actually heard that from Juan of all people.
Oh.
Yeah. He was
our boy.
Yeah, our boy who's now
he was on the podcast once. Fly Me to the Moon, I believe.
Yeah.
One of the early ones.
You get to see where that guy is in terms of like thinking. He's in a whole different plane of existence. But yeah, he told me that one, and I was like, that's actually a good way to remember it. Mm-hmm. The faster you go, the shorter it gets. And just remember that, gentlemen.
Yeah,
that's a good phrasing to remember. But that's how I remembered length contraction and time dilation in some sense. Mm-hmm. But yeah, you will recognize, that's an important lesson to recognize, that your intuition will often fail you.
Mm-hmm. Physics will brutally teach you that. And even in classic mech.
Humble you, yeah.
Yeah, because like things like gyroscopic precession is another one of those mind-bending things. You're just like, how does this make any sense? How is this real life?
It doesn't.
That's the classic, for those who are not familiar, that's a classic spinning tire on a string, and it stays upright. Mm-hmm. You can Google that, and it looks really cool. Maybe I'll even put it on the podcast, but... Yeah, there's certain things that will just defy your intuition.
Or just things that you don't even think about. Like, for instance, like when you open a door, right?
Yeah.
When you're opening a door and a lever and you're pushing, and like one thing I never really internalized was like the shorter the axis of rotation, the closer the distance between the point that you push and the axis of rotation, the harder it is to push.
Yeah.
And that's something that you don't really think about because everything is so prefabricated to fit
to fit our everyday lives. We don't think about that stuff, right?
Yeah. So like, when you see this problem in physics where it's like, the shorter that radius is to the axis of rotation, the harder you have to push. Right. And you start thinking about torque and stuff, and you're like, what is going on? Like, even that will kind of bend your mind a little bit. Angular motion, even when you're talking about how do you say, tension?
Sure.
Which is a weird property, I think, of like solving problems where it'll reduce essentially the amount of work that you have to do to like do something essentially. Mm-hmm. You know what I mean? Like, or leverage. When you gain leverage over something, you can move something heavier by increasing. It's the same principle essentially as like, increasing or decreasing the radius for the force.
Okay.
Right?
Yeah.
Like, that blew my mind because these are classical concepts that are just like based off simple physics.
Right. But not that obvious until you do the math.
Yeah.
Math is so great because it just reveals so much that you don't even realize. Mm-hmm. Like, that's the crazy thing is sometimes people will be like, oh, these physicists are so smart and such geniuses. But actually, really, at the end of the day, not really, because the crazy thing is with physics, once you find the right equation, you get a whole lot of things for free with just the math. Because the thing is, if the math is consistent, it will tell you new things sometimes. Yep. Like, you'll be able to, like, the crazy things fall out. Like with Stephen Hawking, like when he discovered black holes, he didn't just pontificate one day and say, I'm seeing this black hole in my brain. I'm seeing this black hole in the universe. Yeah. I feel like this has to be a real thing. No. Yeah. Like, literally, he takes Einstein's equations and then takes them to the limiting case and then sees, oh, this breaks down and it must actually create a black hole by ripping space-time.
A singularity.
Singularity in space-time. Like, he actually got those from the mathematics. Mm-hmm. Of course, there's some extra work because you have to justify that and say like how that actually fits within the real models of the universe. Maybe clean things up here and there, but really at the end of the day, the math is giving you everything.
Yeah.
So you can get so much out of just the mathematics itself, and really the genius is all in the equation.
Yeah.
You know, of course, it takes real genius to come up with it, but you get a lot of great things once you figure it out.
Yeah, and accurately modeling, obviously, the behavior, too, is critically important to this. Because once you have the model down for your system, the work is done. You're complete.
Yeah.
You can sit back and test limits and all that stuff.
Right. And then if they're working at all levels, then, well, not
done.
all levels, but many levels, at least better than the existing model,
Then you
or if
have
there
a-
is none, then you have something.
Then you have a model.
You do.
Yeah.
So...
Then email that or mail that Nobel Prize over to...
Not us.
Not us. But yeah, is there anything else, I guess, you want to add? If we didn't cover anything
I think
else?
that's it, man. We're looking at 59 minutes, so that's pretty good.
Crazy. But anyway, yeah, so I guess stick around for the outro.
Indeed.
Thank you for making it.
Oh, we're doing the outro.
Yeah, we're doing the outro.
That's right.
Thank you for making it this far into the episode. We just want to actually do a brief shout out to 2 of our patrons.
Yes.
And if you you don't know, we actually do have a Patreon. If you want to go ahead and subscribe, we'll be uploading stuff.
Feed an Eigenbro.
Yeah, feed an Eigenbro.
Donate $1.
Donate $1, yeah. Or 2, or 5, or 10, whatever you want. No, I'm just kidding. But to the shout out to Black Thoughts and
Arya Krish.
yes.
Thank you, guys.
Thank you so much. Shout out to Black Thoughts. I think he's also in Austin.
Yes.
Is that true?
And
Yeah.
also has a YouTube channel.
Yeah, he has a
Yes,
YouTube channel
yes.
too. Yeah. So shout out to him
So
too.
check his stuff out.
Yeah, and for a question, I guess I didn't really think about a question to leave for the audience.
Question to leave for the audience. We could say, what do you guys? I guess did we leave anything out for good tips for potentially learning physics on your own?
Yeah.
Or do you have any more questions about what other ways you can learn physics on your own? And leave it in the comments.
Yeah, or resources too. I think if you have questions like what's a good resource for this, we've been through
Sure.
the ringer. We can discern what's good and what isn't at this point. And yeah, I don't mind leaving a comment for that.
Yes, indeed.
Yeah.
So I guess once again, guys, like, share, comment, subscribe. Check us out on Eigenbros.com, Eigenbros on Twitter, Eigenbros on Instagram, Eigenbros2 on TikTok, and that's it.
Yeah, we'll see you later.
See ya.